Hello everyone. The topic for the day is typecasting. So typecasting can basically help us to convert variables from one type to another. So there are two types of casting that you can do in C++ that are implicit or the automatic typecasting and the explicit that you are going to do yourself. So in case of implicit typecasting, the compiler feels the need of changing the type of the variable from one to another and does that in the background. However, in case of explicit typecasting, we have to indicate to the compiler that we want to change or cast the type of this variable. Now, the first thing that we want to look into is why would we need to have implicit typecasting? So, for example, if there is something like int a equal to 5 and float b, and we want to assign a to b. So what is happening over here is that since a is of type integer, so the compiler is going to first convert or cast this a into float, which will make 5.0, and then assign that value to b. So that is what we mean by implicit typecasting, that the compiler has taken care of this by itself and we don't need to do anything about it. The same way, if we have int c equal to b, so in this case again implicit typecasting is taking place where 5.0, that was a float value, is being converted into 5 as an integer, and then that 5 is being assigned to c, which is of type integer. So in both these cases, implicit typecasting is taking place where the integer is converted into float in this case, and the float is converted back into integer in this case because this one demands an integer value. So that's what we mean by implicit typecasting. Up till this point, implicit typecasting is quite transparent and you won't feel that there is some typecasting going on. However, if we have a mixed expression, for example, int a equal to 5, int b equal to 2, and if I say float c equal to a divided by b. So in situations like this, implicit casting is quite evident. So as we discussed in the operator precedence, division has high precedence as compared to assignment. So first the compiler is going to go with the division. Now both these operands are of type integer, so the compiler would feel that I do not need to change the type in this case. As we saw in this case, integer was changed to float, so it internally changed its type. The same way, the types were not the same. We were assigning a float to an integer, and in this case also the compiler felt the need of changing the type, and it did automatically. However, in this case, the compiler isn't going to feel that need because both are of type integer and we are performing an operation on two integers. So what it's going to do is it will divide 5 by 2, and it's going to have a nameless variable where this value is going to be stored, and since these two variables or operands are of type integer, so that variable is also going to be of type integer. So it's going to store the value of 2 and not 2.5. So when that is assigned to c, c is going to have a value of 2.0 instead of 2.5 because that 0.5 part is already lost as the nameless variable where the division of this was stored was of type integer. In order to tackle with this situation, we have to explicitly tell the compiler that we need a floating point value. So float c, we can rewrite this as float c assignment a division by float b. So over here we are explicitly converting b to float, which means 2 is going to be converted into 2. And now we are having a division between an integer and a float value. So since float is the bigger type, so the variable is going to hold the type of a float, and in that case it's going to store the value of 2.5, and then that is going to be assigned to c. We could have done this to a also, which would mean exactly the same, but at least one of the operand on which we are performing the operation need to be of type float, so that the intermediate variable must be stored in float. If you would have casted any one of it to double, then this would have been stored as a double, and then another typecasting would have converted that double into float because C is of type float. So that's how implicit and explicit typecasting takes place, and now we are going to practice this with code. So this is the skeleton that we use for all our previous programs. Int a, and it has got a value of 5, and float b equal to a. So we are assigning a to b. Cout b. So it displays 5. It didn't give us any error that we are assigning an integer to a float, because obviously the implicit bookmarking took care of it. The same way since b is a float, so if we write int c and we would assign b to it, that would still not give us any error, because in this case the float is being converted into integer. So no problems up till this point, but let's get to the problem that we saw earlier. Int b is equal to 2 and float c is a divided by b. Okay, we need to print this cout c, and the value is 2. So in order to preserve the decimal point, we need to make any one of the two operands as explicitly typecasted to float, and now it gives us a value of 2.5. So in order to understand what's happening, we need to understand what implicit typecasting is, and then if there is such a problem, we need to explicitly typecast our variables. If we change this c to int, so what's going to happen now? First of all, b will be converted into float, then this division is going to be performed. In that case, the new variable is going to be stored as a float value, and then before assignment, that float value is going to be again implicitly typecasted into int, because this c is now an int, and we would come up with 2. So that was about typecasting. Thank you.